So good morning, Los Angeles. How are you doing? Good. So it's a pleasure to be here. Actually, it's my first time at the MEF and the first time in Los Angeles that I found really great city. I have a dual role in Deutsche Telekom. I have responsibility for voice, data, and messaging, as was said, but I am also responsible for service delivery in a company that is fully owned by Deutsche Telekom. It is called PANNet. PANNet stands for Pan-European Network, and the ambition of this company is to become the service provider for all the other Deutsche Telekom operators that are in Europe. So with that, I would like also to introduce you to what was introduced yesterday by JCGA. It was talking about how we have been able to onboard in the PANNet cloud, that is a pure OpenStack cloud, the virtual EPC, so high demanding data plane application. And we have learned, and we want to share with you the learning that we have done in this journey. Of course, when you do this kind of activity, what is really, really important is to do it in an iterative way. So the first learning that I am sharing with you is to do it really with starting from the beginning, starting with a small objective. So your target, you should have a very long ambition, very big ambition, but then you need to drill down it in very small steps. So this is the approach that we have undertaken in Deutsche Telekom. When you start the deployment of a new application on the cloud, what you do is that you start the configuration, the best configuration that you can do at the beginning, knowing all the details. But then what happens is that you start putting the automation in place, you start testing, and you start finding out something that is new, is different, is a blocking point. There is some bottleneck that you need to address. And then you need to, again, put the team together, the competence from the partners, from the, all the skills that you need, and then reiterate. So you solve one problem, and you go ahead, and you find another bottleneck, another problem, and you go ahead, and you continue in this way. And this is normally called in the agile methodology like sprints, and you can have sprints of 1-2 weeks in order to move ahead faster and reach next steps. What we have learned that is quite important is that OpenStack per se is really like the old operating system. So it's not a bottleneck. It can be configured, tuned as you need it. There is all the flexibility that we had in the past, accessing directly the operating system, directly with OpenStack. No big problem. On the other side, when you go for high demanding applications, so applications that need a lot of throughput, what you need to do is that you need acceleration technologies. And you can choose between acceleration technology that are software only, or you can choose with the acceleration technology that also involve hardware. And we did both. Of course, when you go with the software, you have more flexibility. When you go with the hardware technology, you have less flexibility. But if you introduce, as we did, the smart NICs, these smart NICs allow you to have the flexibility that you need. Also, another important thing is not only about performance. It's not only about the throughput. It's also about the scalability, the high availability, the redundancy of the system. And sometimes you find out that there are bottlenecks even there in your cloud environment. And you need to address them with the same principle of iterate and improve at each sprint. These slides show you what we have done recently, very recently in Deutsche Telekom on our cloud. You can see that we are talking about virtual EPC. You have in the application layer, there is the RAN on one side, and there is on the other side the internet access. In the middle, there are the applications that we are talking about. We call it EPC, but in reality, it's 3 components. It is the MME and the 2 gateway, the S gateway and the data gateway. Below, there is the cloud infrastructure that we have developed in PANNet using open source. You can see that we used OpenStack from Canonical and also SDN from OpenContrail. You can see all the details here just to give you, all the information that you need in order to better understand what we have used in order to achieve what we have achieved. And as I said, when you go on the cloud, when you start going on the cloud, when you start experimenting new, new things, you need to have to think about it as a journey. So you know that you are not just installing something and it's done. It's not already optimized by the vendor in their lab. It's something that you need to optimize. It's something that you put on your own cloud, and you need to improve the application and the cloud so that they have synergies and they work perfectly together. And this is not just an installation and that's it. It is a journey. So when we installed this virtual packet core with more than one partner, what we started to see, for example, is that the scalability was not possible to achieve in a traditional way or in the easiest way that you have in mind. When you want to scale up an application, normally what you do? So you run more and more virtual machine. So you have more virtual machine, and then you scale it up, and the throughput goes up, and so on. When you have high demanding data plane application, this doesn't happen because the traffic that is generated among the virtual machine to keep them aligned and synchronized is even bigger than the throughput of the outcome outside. So what we find out is that 40–50% of the CPU was consumed for keeping the virtual machine aligned. And then we, of course, what we did, okay, this is the problem, this is the bottleneck, let's work together with the partner in order to fix it and that's it. And so we did. Fixed that, we found also other problem. When you use DPDK, that is the software acceleration technique, we find out that the queue that were in front of the data plane acceleration were immediately full. So what we did is decided to have a multi-queuing in front of this acceleration data plane, and it worked out. And then also we found out that when you have solved the problem, in the system, then we had some problem with the traffic generator that was loading our system. And then, because it was not properly balancing the links that were available, and to overcome this problem, we also introducing we tried out actually several hashing techniques until we found one that was really able to balance the traffic and use properly all the links that were available. And this we did with a version of our cloud. But then we found out that certain other, to leapfrog, to really go beyond the limits that we have found in this first step of this journey, we had to prove another acceleration technology. So moving from software only to hardware acceleration technology, and we introduced the Smart NIC. The Smart NIC, in order to be introduced, required a new release of our own cloud stack. And so we released it, tested it, and then put it in production. And we are testing it now in these days with really great result. So this is just an overview of the result that we have achieved. Here you can see that in each step of our journey, we achieved a certain increase. So you see that we started with the 12 gigabits in this example with this partner. And then when we optimized the east-west traffic, we were able actually to increase the overall throughput by 51%. What happened next was the multi-queuing. The multi-queuing per se was not a big step forward, but still we gained almost another 10% on top. And then with the hashing, we actually didn't achieve any extra throughput. We just had a better balance of the throughput that were received by the application. Okay. So also, what was also very important is that we continued our journey, and it is not present in this slide because it is very, very fresh, and it was also anticipated yesterday by JC in his presentation, that now with the hardware acceleration technology, we have been able to really increase the throughput enormously, because we moved from about 20 gigabits to more than 60 gigabits. And we are still testing in this moment, and looks like that we can probably reach even higher throughput in the terms of another 20, 30% on top of the 60 gigabits that we achieved so far. So, if I want to summarize for you, my advice is that really OpenStack is our way forward. And of course, you have probably heard about the acquisition of IBM of Red Hat recently, and it's clear that OpenStack is really the future, and at least there is many people that believe in it, and we are among them. It's also important to understand that the cloud is not only for general purpose application, for OTT light application. You can use the cloud, you can use OpenStack also to run high demanding virtual network function. And the journey that we did is a 3-month journey. If we are continuing to do it, and we are always going ahead and having more and more throughput, better result. So for us, it's very important to go in this direction, and also to think cloud. So sometimes it's easier to have a shortcut to think about maybe another a little bit more legacy solution to achieve what you need tomorrow. But with the cloud, with the experience that you need in order to run it, and with this kind of iterative approach that create also in your team more and more skills, more enthusiasm to work together, because when you see that you are improving something that you have developed, and you see and touch with your hands the result, this also create a very good mood in your company. And last but not least, it's very important to test. Testing is very, very important, and also consistency of the test. It's important that you repeat the same kind of test at each iteration, so that you can compare exactly if you have achieved a better result or a worse result, and so on. Of course, test automation, it's very important. So without automation, the cloud itself doesn't bring the value that it should. So test early and often. Automate the life cycle, it's very important. Many talk about continuous integration, continuous deployment. Is really, an iteration of continue to integrate, continue to test, continue to develop, but this should be automated as much as possible. And then also the cloud is for sharing, and this is of course our motto, because in the company that I'm working with, we are serving all the other Deutsche Telekom operator in Europe. That means 12 operators in 12 different nations, and so of course cloud is perfect for sharing. And with that, I thank you for being here.